Medan, the capital city of North Sumatra province, is located in the heart of Sumatra Islands, with plenty of tourist destinations. The city has been very attractive for its business potential in trading and education sector. One of the prestigious educational institutions in Medan is University of Sumatra Utara, the oldest and the biggest public university outside Java that becomes the pride of the people in North Sumatra. University of Sumatra Utara was initiated by the establishment of University of Sumatra Utara Foundation on June 4, 1952. Pioneered by the governor of North Sumatra, Abdul Hakim. The foundation was fully supported by all people in North Sumatra and Aceh. On August 20, 1952, the Faculty Medicine, located on Jalan Seram, was founded with 27 students enrolled. On November 20, 1957, University of Sumatra Utara, known as USU, was inaugurated as a public university by Dr. Insinyur Soekarno, the first president of the Republic of Indonesia. Thus, USU became the seventh public university in Indonesia. Since November 11, 2003, under the Government Regulations No. 56 of 2003, University of Sumatra Utara has changed its status to a state-owned legal entity. Furthermore, based on the Government Regulations No. 16 of 2014, USU has been set as a legal entity public university. University of Sumatra Utara is located on Jalan Dr. T. Mansur, Padang Bulan. USU campus is a green and shady area of approximately 120 hectares. The academic zone accommodates almost all lecturing and practicum activities of more than 50,000 students. In addition, USU also has 300 hectares of land in Kuala Bekala, Deli Serdang, for developing the campus, and 551 hectares of land in the USU Experimental Garden, Tambunan A, Langkat, as the field laboratory. All students' activities are also supported by adequate campus facilities and information technology infrastructures. The learning system is also supported by the main library, which is one of the best libraries in Indonesia today. The main library provides varied collections of learning resources, both in printed and electronic forms. USU has laboratories used for lecturing activities, research, and community service for students, lecturers, and the public. USU provides sports facilities or core and multi-purpose buildings such as auditorium, student open stage, and student hall. To support healthcare, USU has a polyclinic. In addition to the polyclinic, USU also has a teaching hospital, which was officially opened by Director Professor Dr. Runtung SHM on March 28, 2016. Built on the area of 38,000 meters square, the 5-story building hospital is equipped with sophisticated medical facilities. The teaching hospital becomes one of the 24 university hospitals that will be developed in Indonesia.
Oleh karena itu kami menghimbau pada masyarakat, mari bergabung dengan Universitas Sumatera Utara. Universitas Sumatera Utara tetap jaya.
University of Sumatra Utara is recognized as one of the leading universities in Southeast Asia, producing potential and highly competitive graduates with all the accomplishments achieved. To make the good name of the nation a pride for Indonesia.
Danau Toba, keajaiban alam menakjubkan di Pulau Sumatera, rumah bagi suku Batak, telah menjadi perhatian nasional sebagai kawasan prioritas. Salah satu kaldera terbesar di dunia kini telah terdaftar sebagai UNESCO Global Geopark dan menjadikan Toba destinasi berkelas dunia. Indahnya alam danau nan mempesona, budaya yang indah, kreasi yang menakjubkan, masyarakat yang ramah, menjadi dasar pemikiran kami dalam mengembangkan Danau Toba. Destinasi wisata bagi masyarakat lokal dan mancanegara. Kemudahan akses menuju Toba kini telah dan sedang diwujudkan, baik melalui jalur darat maupun jalur udara. Dengan prinsip memajukan tanah leluhur oleh dan bagi seluruh masyarakat menjadi dasar 6 titik pengembangan di Danau Toba ke dalam Integrated Tourism Master Plan. Konsentrasi pengembangan Parapat di area semenanjung Kota Parapat dilakukan untuk meningkatkan performa kawasan sebagai generator aktivitas area. Dengan tata ruang yang lebih menghormati alam dan lingkungan, serta tata transportasi yang lebih baik. Sebagai gerbang wisata Danau Toba yang akan hadir dengan fasilitas berskala internasional. Parapat dengan sejarah nasional di alam inspiratif, gerbang Danau Toba dengan kegiatan MICE dan rekreasi sebagai penggerak aktivitas. Simanindo sebagai area yang khas akan budaya Toba. Hadir sejak zaman Kerajaan Batak, akan hadir dengan peningkatan dan perlindungan performa Huta Batak. Panguruan baru akan menjadi sinergi antara alam dan wisata. Infrastruktur dengan desain berdasarkan nilai kearifan lokal untuk kemudahan perjalanan di Danau Toba yang berkarakter budaya. Sebuah perencanaan berdasar selebrasi alam dan wisata. Bali G hadir dengan tema wisata urban heritage. Menghadirkan proporsi bangunan, jalan, dan pedestrian energi dari kegiatan. Pariwisata yang ramah bagi masyarakat dan penyandang disabilitas. Muara sebagai destinasi wisata Toba yang penuh bingkai pemandangan. Bukit dramatis menuju danau alam indah Muara menjadi sapaan hangat setiap panoramanya. Berfokus pada peningkatan destinasi alam dan kualitas kampung budayanya. Merek baru hadir dengan tema destinasi Nature Eco. Wisata di mana Anda bisa menikmati keunikan alam Toba dengan fasilitas yang bersanding dengan alam serta budayanya. Dan diikuti oleh Toba Caldera Resort sebagai destinasi premium, pionir terhadap kemajuan pariwisata Danau Toba dengan fasilitas berkelas dunia, menjadikannya magnet pariwisata dunia dengan fasilitas golf di tepi Bukit Danau, dilengkapi fasilitas kesehatan bertaraf internasional, hotel dan resort berbintang 4 dan 5 berkelas dunia, dengan total kamar yang tidak kurang dari 3.000 ruang untuk menikmati rona alam yang inspiratif khas Danau Toba. menjadi tuan rumah event dunia di Rona Alam khas Caldera. Di Alam Toba dengan pengalaman mengagumkan. Selebrasi keindahan alam, budaya, dan wisata. Toba Caldera Resort sebagai pionir wisata kelas dunia menyajikan petualangan penuh pengalaman dan kebahagiaan akan warisan budaya di alam surga kaldera dunia di tanah suku Batak.
Medan, the capital city of North Sumatra province, is located in the heart of Sumatra Islands, with plenty of tourist destinations. The city has been very attractive for its business potential in trading and education sector. One of the prestigious educational institutions in Medan is University of Sumatra Utara. The oldest and the biggest public university outside Java that becomes the pride of the people in North Sumatra. University of Sumatra Utara was initiated by the establishment of University of Sumatra Utara Foundation on June 4, 1952. Pioneered by the Governor of North Sumatra, Abdul Hakim. The foundation was fully supported by all people in North Sumatra and Aceh. On August 20, 1952, the Faculty Medicine, located on Jalan Seram, was founded with 27 students enrolled. On November 20, 1957, University of Sumatra Utara, known as USU, was inaugurated as a public university by Dr. Insinyur Soekarno, the first President of the Republic of Indonesia. Thus, USU became the seventh public university in Indonesia. Since November 11, 2003, under the Government Regulations No. 56 of 2003, University of Sumatra Utara has changed its status to a state-owned legal entity. Furthermore, based on the Government Regulations No. 16 of 2014, USU has been set as a legal entity public university. University of Sumatra Utara is located on Jalan Dr. T. Mansur, Padang Bulan. USU campus is a green and shady area of approximately 120 hectares. The academic zone accommodates almost all lecturing and practicum activities of more than 50,000 students. In addition, USU also has 300 hectares of land in Kuala Bekala, Deli Serdang, for developing the campus, and 551 hectares of land in the USU Experimental Garden, Tambunan A, Langkat, as the field laboratory. All students' activities are also supported by adequate campus facilities and information technology infrastructures. The learning system is also supported by the main library, which is one of the best libraries in Indonesia today. The main library provides varied collections of learning resources, both in printed and electronic forms. USU has laboratories used for lecturing activities, research, and community service for students, lecturers, and the public. USU provides sports facilities or hall and multi-purpose buildings such as auditorium, student open stage, and student hall. To support healthcare, USU has a polyclinic. In addition to the polyclinic, USU also has a teaching hospital, which was officially opened by Director Professor Dr. Runtung SHM on March 28, 2016. Built on the area of 38,000 meters square, the 5-story building hospital is equipped with sophisticated medical facilities. The teaching hospital becomes one of the 24 university hospitals that will be developed in Indonesia.
Oleh karena itu kami menghimbau pada masyarakat, mari bergabung dengan Universitas Sumatera Utara. Universitas Sumatera Utara tetap jaya.
University of Sumatra Utara is recognized as one of the leading universities in Southeast Asia, producing potential and highly competitive graduates with all the accomplishments achieved. To make the good name of the nation a pride for Indonesia.
The parallel session can be seen on the screen. Okay. And for the participants, if you already use Zoom version 5.3.1, you can see in the bottom of your Zoom screen, there are 4 white squares, and click the respective room. The name is breakout rooms. You can click join and you will be automatically entering the chosen room. With this option, you can also move to another room in the middle of the session by clicking Leave Breaking Room, and you will be directed to the main room. Then you can click again the breakout room icons. If you are not using the Zoom version 5.3.1, we can also help you to enter the room of your choice, but you need to rename your username in this format: name, institution, room number in invited speaker presentation, and room number in oral presentation session. There are an example that we provide in the chat. So for example, if your name is John, your institution is ITB, and you will join the invited speaker presentation room 1 and oral presentation room 1. So you rename your name John, ITB, room 1, room 1. A little bit of information. If you're not familiar on how to rename your name in the Zoom,
Medan, the capital city of North Sumatra province, is located in the heart of Sumatra Islands, with plenty of tourist destinations. The city has been very attractive for its business potential in trading and education sector. One of the prestigious educational institutions in Medan is University of Sumatra Utara. The oldest and the biggest public university outside Java that becomes the pride of the people in North Sumatra. University of Sumatra Utara was initiated by the establishment of University of Sumatra Utara Foundation on June 4, 1952. Pioneered by the governor of North Sumatra, Abdul Hakim. The foundation was fully supported by all people in North Sumatra and Aceh. On August 20, 1952, the Faculty Medicine, located on Jalan Seram, was founded with 27 students enrolled. On November 20, 1957, University of Sumatra Utara, known as USU, was inaugurated as a public university by Dr. Insinyur Soekarno, the first president of the Republic of Indonesia. Thus, USU became the seventh public university in Indonesia. Since November 11, 2003, under the Government Regulations Number 56 of 2003, University of Sumatra Utara has changed its status to a state-owned legal entity. Furthermore, based on the Government Regulations Number 16 of 2014, USU has been set as a legal entity public university. University of Sumatra Utara is located on Jalan Dr. T. Mansur, Padang Bulan. USU campus is a green and shady area of approximately 120 hectares. The academic zone accommodates almost all lecturing and practicum activities of more than 50,000 students. In addition, USU also has 300 hectares of land in Kuala Bekala, Deli Serdang, for developing the campus, and 551 hectares of land in the USU Experimental Garden, Tambunan A, Langkat, as the field laboratory. All students' activities are also supported by adequate campus facilities and information technology infrastructures. The learning system is also supported by the main library, which is one of the best libraries in Indonesia today. The main library provides varied collections of learning resources, both in printed and electronic forms. USU has laboratories used for lecturing activities, research, and community service for students, lecturers, and the public. USU provides sports facilities, and multi-purpose buildings such as auditorium, student open stage, and student hall. To support healthcare, USU has a polyclinic. In addition to the polyclinic, USU also has a teaching hospital, which was officially opened by Director Professor Dr. Runtung SHM on March 28, 2016. Built on the area of 38,000 meters square, the 5-story building hospital is equipped with sophisticated medical facilities. The teaching hospital becomes one of the 24 university hospitals that will be developed in Indonesia.
Oleh karena itu kami menghimbau pada masyarakat, mari bergabung dengan Universitas Sumatera Utara. Universitas Sumatera Utara tetap jaya.
University of Sumatra Utara is recognized as one of the leading universities in Southeast Asia, producing potential and highly competitive graduates with all the accomplishments achieved. To make the good name of the nation a pride for Indonesia.
keajaiban alam menakjubkan di Pulau Sumatera, rumah bagi suku Batak, telah menjadi perhatian nasional sebagai kawasan prioritas. Salah satu kaldera terbesar di dunia kini telah terdaftar sebagai UNESCO Global Geopark dan menjadikan Toba destinasi berkelas dunia. Indahnya alam danau nan mempesona, budaya yang indah, kreasi yang menakjubkan, masyarakat yang ramah, menjadi dasar pemikiran kami dalam mengembangkan Danau Toba. Destinasi wisata bagi masyarakat lokal dan mancanegara. Kemudahan akses menuju Toba kini telah dan sedang diwujudkan, baik melalui jalur darat maupun jalur udara. Dengan prinsip memajukan tanah leluhur oleh dan bagi seluruh masyarakat.
I'm a lecturer in electrical engineering, University of Sumatera Utara. Today I will be your moderator. Today we have three presenters that will present our interesting session. Today we have Mr. Ricky Elson from Lentera Bumi Nusantara, and secondly Mr. Jesus from Siemens, I believe, and third will be Mr. Fahmi from Electrical Engineering Department of University of Sumatera Utara. Actually, Mr. Fahmi will be is my boss in the university. Okay, so we can start by listening to presentation. It should be Mr. Ricky Elson first. Is Mr. Ricky Elson available, Farhan?
Not yet, sir.
Hello? Hello? Hello?
Yes, is Mr. Delefante in this room, sir?
Yeah? Yeah? Pardon? Hello? Sorry.
In ahead, there is revolution in energy. So what we must do? We must pick up the future, and we become leader in our country. So there is no foreigner or the funding lembaga keuangan apa bilangnya, international funding drive our decision about the energy. We must independent from them, from their intervention. We must independent, create something, create the renewable energy. And our university and research center can provide this one. Okay. Solution. From my expertise, and the Jendra Matis said, in my dalam istilah saya, sorry, I combine with bahasa to make my presentation looking fluent and smooth. Jendra Matis said, we must divorce, fully divorce and independent from the land base. What does this mean? Even when the army deploy in the field, okay, freedom from the land base. So there is no problem with resupply water, resupply fuel. How to fulfill the requirement? So the consequence, we need to dance from the kind of energy source and portable to deploy in the field, free from no fuel shortage forever. It's looking as sound utopist, but is it possible to do that? I think it's possible. The Department of Defense US asked the nuclear company in the US, can and possible the nuclear company to provide the small modular reactor, even nano nuclear reactor for the army. So imagine when I will talk in bahasa to make it comprehensive understanding. Coba bayangkan jika Kostrad pergi ke suatu wilayah operasi, mereka membawa mikronuklir gitu. To support apa? Support everything. It's, I think, very nice. It sounds very nice. But the USS can already done the 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 imagination. They asked the company to provide the nuclear. The right side is the figure about the nuclear reactor design. The fuel is uranium, and the interesting from this design is how to transfer heat from the core to end of the generator. They use the heat pipe. Heat pipe is revolutionary in the heat transfer model. So I think many innovation can be applied for the energy area. For example, in okay, I will talk about the small modular reactor. What is a small modular reactor? Then our figure dalam bayangan apa? Dalam our imagine when we imagine about nuclear reactor, it's very huge, very risky, and very dangerous, very huge to produce electricity. It's the nightmare imagination about the nuclear. But when you going to France, there is ada pameran mode dan gadis Prancis cantik-cantik. The nuclear 70% electricity generated from nuclear in France. But the French is enjoy. The people of France is enjoy. But Macron is different, okay? Okay. Gen 4 reactor. Right. Now for 2020 until 2030, the nuclear reactor generation come to Gen 4, generation 4 for nuclear reactor design. And Gen 4 need some requirement: safe, sustainability, economical, proliferation, resistant, and physically secure. This is requirement. It must be fulfilled for the every nuclear producer or every nuclear engineer must provide the requirement. Okay, there are 6 innovation of Gen 4 reactor nuclear. There is sodium fast reactor, there is lead fast reactor, there is gas fast reactor, very high temperature reactor, and supercritical water reactor. And the last is, I get the red circle, is molten salt reactor. I will discuss the reactor. What the interesting from the molten salt reactor? The main characteristic from the molten salt reactor is contain a hot liquid salt with a nuclear reaction take place. And the salt consists of nuclear fuel and several other compounds that optimize the reaction, the heat transfer, and stability in salt. This means the salt mixture in the both of fuel and the coolant. This allows for high heat protection. Because salt has the high heat capacity, so the reactor can be operated in the atmospheric pressure. When the operation in atmospheric pressure is secure, so there is no dangerous part in here. For example, high pressure, you need the special material, special treatment, special material, special maintenance to profit the system. But the system is simple compared to other reactor. Okay. MSR terminology. There is integral and loop. And okay, MSR can support the renewable energy. For example, the integral type of the reactor, the heat from the core can be used to produce hydrogen to support renewable energy, future clean energy. Second one, in the domain of the chevron, the fuel is high very viscosity value. So this is problem to come out from the air. So when they use the reactor, injecting the hot steam on the earth, so make the viscosity from oil is decreased by heat temperature. So the oil can be come out from the earth. Okay. The second one is looping. Loop type of the MSR terminology is used for the electric productivity. Okay, to produce electric. Okay. this is detailed design. I take design from Torcon, MSR loop. Okay, there is 3 in the right circle. There is 3 looping: primary heat exchanger, secondary heat exchanger, steam generator. There are 3 heat exchanger. So heat exchanger apply a key rule in the nuclear reactor. So the part is need innovation to downsizing the size of reactor. Okay, compact heat exchanger. The left picture is the molten salt reactor. The 60 years ago, the American already telah menerbangkan pesawat terbang dengan mesin reaktor nuklir berbasis molten salt. It's very amazing. It's the achievement in engineering 60 years ago. The left is the reactor that really reactor can be built and running, yang sudah berjalan dan benar-benar dibangun. But the problem is number 2, heat exchanger, because there are 3 heat exchanger in the system. So we must modify and improve the heat exchanger. So I propose the compact heat exchanger to respond space saving, lightweight and economical heat exchanger. And the main characteristic of heat surface area density, because the heat transfer is in the forced convection and single phase. So the heat transfer area, the K component or K factor to enhance the heat transfer. Okay, I will review the primary heat exchanger. First is compact heat exchanger, Prince Circuit heat exchanger, and the second one is review of Oak Ridge 8 megawatt thermal. The PCSE, Prince Circuit heat exchanger, is part of the compact heat exchanger. The main characteristic of the Prince Circuit heat exchanger is supported by 2 methods, 2 technology: chemical etching to make a microchannel pattern on the plate, and second one is how to compose every plate become one system. We call the Prince Circuit heat exchanger. They are diffusion bonding. This is challenge for us to predict this one. Okay. Okay, this is a cell tube heat exchanger from the Oak Ridge heat exchanger. The type is the tube, U-bend tube, and inside on the cell, and the length is in this case using feet in the American measurement. And next, I will convert in the meter, and this one is low efficiency. So so when we use the Prince Circuit heat exchanger, the main advantage and disadvantage from the Prince Circuit heat exchanger for salt, okay, salt and salt, not general, not salt and salt. High heat transfer density, 2,500 meter square per meter cubic. High maximum operating temperature, 900 degrees Celsius. High effectiveness, in order close to 100%. Small pressure drop, light and compact. But disadvantage is new technology and ongoing development of material. Okay, note for the 2 point, the last 2 point. This is we call this, the call is new technology and ongoing development is for MSR area. This is a mature technology, but in the MSR area is a need research for the material. I'm sorry for the picture. I forgot to write the citation in here. I'm sorry, I'm forget. It's not my picture. Okay, I said my apology. Okay. Next, result and discussion. Okay, I will check the performance of Prince Circuit heat exchanger on molten salt reactor from Oak Ridge. And second one, I change the power for 8 megawatt thermal to 550 megawatt thermal based of material, fuel cell, new material vs Oak Ridge National Laboratory. We use the molten salt from Oak Ridge as benchmarking, and Prince circuit was used tip counterflow, and channel shape is semicircular. This is illustration. Left side is the old type of the heat exchanger. The length of tube is 4.3 meter, and the cell is 2.464 meter. And right side is illustration of the Prince circuit heat exchanger. Length is decreased extremely. From the cell 2.4 meter become 0.30 meter. So it's a very compact, very small, okay, compared to the old one, okay. So this is a detail calculation for my work, and the fuel cell is FlyNet, lithium fluoride, beryllium fluoride, thorium fluoride, zirconium, and uranium fluoride. For the coolant is lithium fluoride, beryllium fluoride. Number of channel is close to 50,000 channel for hot cooled and cooled side, and pressure drop is very low, 0.3, and effectiveness is 0.580, and pumping power is 0.5 kilowatt, almost same between cooled and hot side. Material has alloy, and volume of primary heat exchanger is 0.037 meter cubic. Amazing. When the power is changing from the 8 megawatt thermal to 500 megawatt thermal, the dimension is quite small. Length is ONIS and new material is different, okay, but still quite small and low dimension. But physical properties from fuel salt, coolant salt, and material is affected on the dimension from the heat exchanger. Okay. Okay, I will jumping the figure because it's okay. I jumping.
Pak Bambang, we still have 3 minutes more.
Okay. The challenge is how to produce the Prince circuit heat exchanger. Previous, I said that using the etching method to make a micro channel pattern, but in this case, I try to make a micro IDM combined with CNC. But to bonding the layer by layer, I still use the diffuse bonding. Okay, reason you can see from this page. Okay. This is illustration. How to fabricate the micro channel over the plate. Okay, CNC to make Pola HJ, and multi electroda micro IDM to make to scrape micro channel pattern. Okay. Next, this is diffusion bonding. Okay, plate, hot plate, and cold plate, and intermediate plate combined become one system. Using the diffuse bonding, the key factor, 2K factor to make a bonding, pressure and temperature. And interesting, if when can propose new method for make bonding. Okay, this is my conclusion or recommendation. Small modular reactor has potentially to contribute in defense area, especially on the elite unit where need mobility and in massive operation. Molten salt reactor is best choice due to the simple design and application. Prince circuit was reducing the dimension of molten salt reactor compared to the cell to heat exchanger. Department of Defense must be explored, and the domestic potential from research center like Batam and university also not only encourage but give the research funding for studying the small modular reactor both in civil and military application respectively. Potentially to produce domestically the important subsystem in the reactor that is heat exchanger tip print circuit heat exchanger. Okay, thank you, Sensei Bindur, for
Thank you.
opportunity.
Thank you very much, Dr. Eng Bambang and Joko Suroto. Let's give a big round of applause for Dr. Eng Bambang Joko Suroto.
Thank you, thank you, thank you, thank you.
Then let me call Bapak Yani, Bapak Kolonel Yanif. Are you here?
Yes.
I'm sorry, big apologize from me because I decide to continue the presentation to the second presenter. But now we are going back to your presentation. Can you present your presentation, please, Bapak Kolonel Yanif? Okay, thank you.
Okay. Okay, I can continue to my presentation from slide to 5. In state defense, is all effort to defend the sovereignty of the state, the territorial integrity of the NKRI, safety of the entire nation from threats and disturbance to the integrity of the nation and state, which reign in a universal system. In this graph, this name to triple helix model is the three variable is in territorial integrity, and the second to the safety of nation, and the third to sovereignty. And side in the graph of on one of in its manifestation is bela negara attitude as a behavior of the nation that imbued by their love of NKRI, which is based on Pancasila as constitution in ensuring the survival of the nation and state. In this name graph is the Panca helix model. Described is the bela negara action is the love the country, and the first to the second to believe Pancasila as national ideology, the three of willings to the sacrifice for the nation and country. So then have ability of bela negara, and the last of awareness of the nation and state. This is slide in describe to the energy security, to the national security to the political security, economic security, social security, and culture security is the support from energy security. Next slide, and energy security to the national security, the component that support national security from demand to the transportation, industry, household, building, or others is the demand that should be balanced against supply. Is from to the fossil and renewable energy. In this slide is the energy security to the political energy in the cycles to conflict potential in distributing the energy. to the dominant group of people join in the process of distribution and short allocation. 2. Every Polish suggestion has right. 2. The initial cycles, the conflict potential. And Polish dynamic in energy sector is the exploration and exploitation energy search. To geopolitical factor indicated the energy price, and the third international partnership. So then basic and certainly law in energy sector, especially in private sector. And the last in investment in the energy sector. In this graphic, energy security and political security, we can see from the chart, politics affect the increasing and decreasing of world oil price. The firstly, conflict between the country as a highest energy producer and highest consumer. The secondly, International Oil Organization OPEC decision to cut the oil production when the demand was increased, so the oil price increased. And the thirdly, US as the highest oil consumer in the world had oil crisis and made the oil price became to $130. And then describe the energy security, political and security. The drastic decline was triggered by a breach in oil supply. The two decreased oil use will at the same time the volume of oil production remained the same. As a result of this situation, the contract price had to drop significantly and enter negative territory, so that oil buying and selling transaction did not proceed, and usually seller receive payment from the buyer, but now at a minus price of oil. On the contrary, the seller has to make a payment for each barrel of oil to the buyer. This is stable and great and energy security to dependent economic security. There was a decrease in export and an increase in import every year. PNPB, penerimaan negara bukan pajak from the SDM sector. And then the energy security dependent to economic security, the contribution of tax revenue continue to be optimist and quality state spending is increased. This is modeling concept. Is my name, our name in the Indonesia Defense University is the energy modeling concept supports defense and defense support energy. In the left, my name, our name is the quantiple helix model is the 4R plus 1S. The first R is availability, the second to the acceptability, so then acceptability, then affordability and sustainable is the model. The name is quantiple helix model. So then quantiple helix model from the stakeholder energy is the defense, industry, academic or lecture research on BUMN to go to and the public. And so then the triple helix model is the state defense, is the three variable: territorial integrity, safety of nation, and sovereignty. And so then to the Panca helix model is the bela negara attitude, love of country, belief Pancasila or as national ideology, willing to the sacrifice for the nation and country, so then have the ability of bela negara, and the last then awareness of the nation state. The example of energy support defense and defense support energy, instalasi of solar panel from Indonesia Defense University in Mako, Markas Komando, Brigade Infantry 3, the Pasmar 3, Pasukan Marinir 3 di Kota Sorong, at the 77 Agustus 2019. In several described to the energy security in social security culture, energy support school activity, so then energy processing into biogas sebagai waste to energy, so then energy support procurement of clean water, order to the energy support tourism, energy support street lighting, and energy support to household. The challenge of energy sector is demand projection of energy demand, energy development in Indonesia, and project Indonesia energy balance on 2025. Energy sector challenge is for the special, the first in oil. The problem is the energy supply crisis, and then lack of infrastructure, then to the lack of strategic reserve and natural resource management. To the second, in the problem in the lack of distribution infrastructure, and then lack of distribution infrastructure in downstream city gas network, uncertain of demand, take or pay mechanism because there are no off-takers and production, and human resource capacity of in not optimal. And the third goal is the high externalities, pollution, environmental and social damage, and government commitment to reduce greenhouse gases. And the last, to the renewable energy, not yet independent to the technology, and the human resource capacity is not optimal. Price agreement between PLN between PLN and IPP, and different resource regional potential. Next slide.
Maybe 2 minutes more.
At the sector strengthening, yes. The first deposition, increase production or reserve of oil and gas, make exploration easy, provide fiscal incentive, fix of the rule or regulation, and the second devotion and reduce fuel consumption and imports, use alternative energy source, biofuel mandatory, and conversion of fuel to natural gas or others. The devotion push massively the development of renewable energy, take advantage of various energy sources from geothermal, water, biomass, solar, or others. And the fourth devotion, energy saving, make it a community movement that life energy saving. This is the four devotion of energy. Energy and industrial 4.0, digitization of the economy and other fields to meet the increasing demand of energy. The COVID-19 pandemic has helped acceleration and digitization in order to maintain the stability of the country. Aspect that can fulfill energy security must be considered because it is closely related to national security. Thank you.
Thank you very much to Bapak Kolonel Laut Dr. Insinyur Dhani Dwi Kunchoro. Let's give a big round of applause to him. Okay, now we would like to continue to our third presenter. His name is Bapak Benny Suryadi, STMT, Manager of Power, Fossil Fuel, Alternative Energy, and Storage, ASEAN Center for Energy. Bapak Benny Suryadi, the time is yours now, and hopefully you may finish the presentation around 20 minutes or 25. Thank you.
Thank you very much, Dr. Taufik. Selamat siang, selamat sore. Greeting from Jakarta, everyone. First, I would like to convey my highest appreciation to the organizers for inviting me to join this important event, the timely event on the discussion about energy and defense in the Indonesia context. So, it's my honor to join this important event along with Colonel Dr. Yani and also Dr. Bambang. In this opportunity for around 20 minutes or less, I would like to share some insight on related to the session that we have this afternoon about the energy and geopolitical implication from Indonesia and also Southeast Asia region. And then I will touch a bit about the COVID-19 pandemic that we are currently experiencing. But I start with also the introduction of the institution I'm working on. I'm working from the ASEAN Center for Energy. This is the intergovernmental organization in the Southeast Asia region. So we are representing the interests of the 10 countries in the Southeast Asia region, Brunei, Cambodia, Indonesia, including Indonesia, as well as the other country come to alphabeted, including Vietnam. So our headquarters is in Jakarta, as Indonesia as one of the founding father for the ASEAN institution. Our work is serving the interests of the 10 countries, so equally to all of the 10 countries, so in not only Indonesia, but here I'm trying to also present, give some insight for the Indonesia context. But in general, I think it's similar with the goals of the energy for every countries in this region or in the globals, that we aim to achieve the energy security. We aim to achieve the energy accessibility from people in Jakarta or people to Papua to have the same access to the energy. We aim to also achieve the affordability, the willingness to pay, the willingness to buy the energy for all the peoples in these countries, and sustainability for all, meaning to say it's responding well to the concern of the environmental. This is more or less similar with what Colonel Dr. Yani mentioned about the concept of the energy principle itself. And at this point that I would like to touch more about the energy security. But on top of that, in ASEAN, because we are looking for all option of the energy, be it nuclear power, as Dr. Bambang has mentioned, and then we also look into renewable energy, the energy efficiency, clean coal technology, promotion of the utilization of clean coal technology, and also carbon capture and storage, as well as ASEAN power grid and trans-ASEAN gas pipeline, which I touched more later. What is my institution working as a think tank and providing the data and knowledge hub, so we compile all the energy information from all of the 10 countries, including Indonesia. And then we also act as a catalyst for the energy collaboration among the countries in the region. And here, general story, Colonel Yani is also already mentioned, in particular for the energy profile in Indonesia, that currently, this is the picture for 2015 that I took from the recent publication from the Dewan Energy Nasional, October 2020, where are we right now on our energy mix. But for sure, that still around more than 80% of the energy profile or the energy mix in Indonesia is coming from the fossil fuels. The latest record is only saying around 9% of the energy in the Indonesian energy mix is coming from the renewable energy. So oil, gas, coal is the major part of our energy mix. And today, and it's expected, or according to the national energy policy, that even until 2050, the majority of the energy is still coming from the fossil fuels in Indonesia. This has become a big concern on how we are going to fulfill it, how to secure the supply of the energy for Indonesia context. But in ASEAN level, the picture is also similar. More than 80% of the energy supply in ASEAN is also coming from the fossil fuels. Today is only around 13% of the energy mix in ASEAN, in Southeast Asia country, as if we combine together, is coming from renewable energy. So more or less the same figure that we have in Indonesia. And also the same figure for the projected numbers. Until 2040, that fossil fuel is still considered the major fuels for the countries in Southeast Asia. So it's not only the story for Indonesia, but it's also other countries like Thailand, Malaysia, or the Philippines. That's bringing the issue of raising the concern about the energy security. I touched again what the presentation from the Colonel Yani about definition of the energy security according to Indonesian law. So every country in 10 of the countries in Southeast Asia has a different way in defining the energy security. Indonesia, for example, we quite rich on coal, so we are not really putting an issue about whether we have coal or not, because we have abundant resource. So the supply of coal is not our concern. But oil, in another story, is the import. So supply on oil is a concern for us in defining the energy security. in particular that more oil is being imported compared to the domestic production today and also in the future. So every country has a different way in defining the energy security. Small country like Singapore, they don't have any fossil fuels, any resource at all. Maybe to some context, they have a solar potential, they have fine, but also for having a concern on the oil security relying to the Singapore's natural gas is also the same story. Indonesia has a huge reserve of natural gas before, still to some context today, and then expected for the coming year, we are still producing quite a amount of gas. But again, country like Singapore has a solid infrastructure to define the energy security. In fact, they have the biggest LNG receiving terminal in ASEAN, with more than 1/3 of the capacity is in their facility. So that's how many countries defining about the energy security, about the security of supply, the ability to meet the demand if the supply shock occurs. Colonel Yani also mentioned before about the crisis, the war, the oil shock that we're having. So whether the countries, particularly Indonesia, having ability to meet if the supply shock occur, if there's something happen, or if they're being hijacked along the way. Then also about talking about the strategic fuel stock. This is also mentioned by Colonel Yanis before about the strategic reserve that we have, and the energy diversification. We are still around 80% is coming from the fossil fuels today. 20 years ago, it's also around 80% of the coming from the fossil fuels, and this is still projected the same story in the next couple of decades. So there is a concern on the energy diversification. There is a concern on independent and self-sufficiency. We are, at some context, is still exporting natural gas, but also countries, Indonesia is also starting to import the natural gas. And then last but not least, about the secure and solid infrastructures. We experienced a big blackout in Jakarta and then across the Java before. This become a concern for the security as well, because it's impact a lot of things, and maybe also because Dr. Bambang and Colonel Yani is coming from the military side. It's also impact the military units, because once your energy is stopped, then your facilities become in concern. So about the safety from the infrastructure, the electricity infrastructure is become critical. And now, as the world is going digital, more and more power plant or the infrastructure is being connected to digital, the cyber threats become more concerned on the energy security. So people not only talking about whether you have a supply or not, but it's also have a concern whether our facility on energy have a solid protection, a resilient protection into the cyber threats, into the hijacks by this cyber security threat. So there's a growing definition about the energy security, but I think, of course, that's as Dr. Yanis mentioned, that the also point of view is military to secure, to put the national interest on top of that, become a critical component for the countries in defining the energy security. And I have touched it before that for many years we are focusing about the energy security to simplify it, whether we have the supply or not, whether we have the production or not. 20, 30 years ago that we are so abundant with the oils. Nobody think that we are going to import oil, so we are happily use it. But then come the day where Indonesia is starting to import the oil, and then the security of energy security become a concern. Natural gas is also the day we think, oh, we have a lot, and we make the export of natural gas because at some point, yes, it's generate the income, generate economic development for the countries, but also in other side bring the concern on the energy security for domestic players. Coal, we still have more coal compared to the oil and gas, but it's also not for so long. It's going to be, we may have longer, more stock on our hours, reserve on hours fossil fuel compared to the other country. But thing to remember is also we are a very big country, 260 million people. That if we are not securing this supply well, that it will become a more and more concern for the countries to define the energy security. And then, as you know, we are in ASEAN. We have a neighboring countries like. We also very good neighboring, but to some context, the countries will also compete with other to fulfilling their domestic needs on the energy security. Then I will share two infrastructure projects that shaping the regional energy security. Maybe some of you familiar, maybe not, but we have the first project that I would like to share. This is a regional project. It's not only the Indonesia project, but it's a regional project on the electricity. It's called the ASEAN Power Grid. The basic idea is to connect all of the electricity infrastructures in Indonesia, in Thailand, in the Philippines. It become a big, major integrated system. So maybe at some point the idea is maybe your house for example, I'm coming from the West Sumatra. Maybe one day that my home in the Padang, West Sumatra, the electricity that I connect, maybe it's coming from Laos, maybe it's coming from Thailand. So this is the idea is being developed at the regional level where we trying to connect the electricity. The idea is very good because once you connect each other, because we can sharing the resource, we can optimize the cost, and also we can each other supply the needs, whether, for example, to some context in Sarawak or Sabah, for example, right? In the border area of the Kalimantan to the Sarawak and Sabah, we have a demand. We have the people who need electricity. But building our own power plant will be very costly. And connected to a system in Sabah and Sarawak will be much cheaper, bringing this kind of infrastructure. So this is the idea. It's very noble idea to connect it. But then also another side, it might also trigger the energy security for each particular countries. And how the different of the readiness of the infrastructures in Sumatra when it's being connected to the Malaysia, which is more advanced, or when connected to Singapore, which is also more advanced, with receiving a threat on the cyber security when it's being connected. So this is what happened at regional levels, that where Indonesia might need to look the country inside, but it also need to look what happened on the regional level, because this also shaping the regional energy security. That's on the electricity. Then I will move to the oil and gas issue. This is what we call it Trans-ASEAN Gas Pipeline. The idea is also similar, that we have several gas fields in the region, then we can connect it and through the pipeline, and then the gas can be transport to the countries in region. So we can, as a neighboring country, we can support each other. This is the idea that being established as well. It's to some point is rely about to East Natuna, which is not being materialized until today. Then because the concern of this pipeline, that people starting to look, okay, pipeline is not working, so the country is starting to build the LNG regasification terminal. This is where the country is also trying to be connected, but at some point, I bring my point before that several countries, our neighboring countries, trying to build or even already built the regasification terminals, importing the oil and gas from the East, from the Arab, from the other country, from the Qatars, and then become a hub for the regional. So at some point, maybe we are going again. At some point, maybe Indonesia, we are exporting natural gas now. It's more importing on the natural gas, but maybe in the future, that if Indonesia is not properly define our energy security plan for the infrastructure, maybe we're going to import it from Singapore, and that's where the regional, the national energy security is defined the infrastructure from the other country. One way is a good thing because it creates the economic interaction, it creates the security between the countries where the interaction happen. But at some point, it must also properly addressed as a concern about the national energy security. Currently, we have 9 LNG regasification terminals in 4 countries, including Indonesia, with the total capacity combined around 338.75. Indonesia is only a small portion on that one. We have Singapore with the 11 MTPA, Thailand and Vietnam is also has more numbers. So it's also defined how the regional energy shape the national energy. And that will be my last slide. Then I'm talking about the COVID-19 pandemic that we are experiencing today. It hits everyone. It brings the impact significantly to everyone, to every sectors, including the energy. I mean, the economic growth, of course, the challenge that we have, economic slowdown, a lot of business being bankrupt, the economic activity slowed down, leading to the lower GDP growth, also lower the demand, the energy demands. On the power, the many power projects are being halted with the supply chain disruption, and then oil and gas, even though we are experiencing the lower oil price, we think it will be a good one, that having lower oil price, but because the demand is also slowed down, so that is a challenge that we are facing. And then what's the opportunity is also missing that I highlighted that on the power project, that's many project is being halted, and because the supply chain disruption, where the global chains on this is being disconnected because somehow our border is being closed. We cannot import from China, where many of our power in the power project is supplied today. So we cannot import that. Supply chain is disruption. But then we miss the opportunity that where everyone is like, okay, we cannot import from the neighboring country. Let's try to build our in-house, our domestic production. But then this is how is the opportunity to design the energy security, taking the advantage of the COVID-19 pandemic. Lower oil prices also at some point may be a blessing at this case. The oil, even Dr. Colonel Yani mentioned that oil very low, even at some point reaching the minus pricing. But then we don't have the infrastructures to stock it. We don't have the infrastructure to buy it and keep it for our energy security in ASEAN. So this is a challenge that we have on defining the energy security, in particular during this COVID-19 impact. And of course, talking about the economic slowdown, the energy affordability investment is become lower. But then it's always two sides of coin. Wherever the challenge, there is the opportunity that we need. There is available opportunity to build a more affordable, environmentally friendly recovery plan. The opportunity to revise our development plan and design a properly policy to cope with the latest plan, and the opportunity to rethinking about the oil stockpiling, rethinking about how to reduce the burden on oil import costs as well as fossil fuel subsidy, and in the longer time to really put this as the opportunity to redefine what is the energy security for Indonesia in the futures. again, back to my first slide, that is not only about the having a secure supply, but it's the whole complete story. And then also with all the digital work now, cyber security is very, very challenging for us. That's end of my presentation. Feel free to visit our website for more information or for the discussion. Thank you very much. Back to you, Dr. Taufik. Thank you for the opportunity.
Thank you very much. Thank you very much, Mr. Benny Suryadi STMT. Let's give a big round of applause for Mr. Benny Suryadi STMT. Okay. And then, very well, ladies and gentlemen, now we come to question and answer session. But we only have a short time, maybe around 5 minutes. So at the moment, we have one question from Mr. Ricky Andrian, PLN, to Mr. Benny. I think PLN has already been assigned to build a 35 gigawatt coal power plant from government. Unfortunately, nowadays, PLN faced with pandemic COVID, which make the system under demand. Other side, we should build 23% renewable energy in this situation under demand. What is your opinion and suggestion about this? Thank you. Can you, Mr. Benny, address the answer to the question?
Thank you, Dr. David. Thank you, Pak Ricky and Rian, for the question. It's not that easy to respond it. But if I can say that yes, we have a target, 23% target, and also about the appointment assignment to build a 35 gigawatt power plant in total. My understanding is not only from the coal, but it's also to some portion is expected to coming to renewable energy. This, I mean, at some point, I think the pandemic is giving the opportunity for us to rethinking about the plan that we have right now. It's also the opportunity that us in ASEAN level, we also define it whether 23% is something that we still pursue with the current situation, or we just keep it, or whatever the situation. But that will bring an impact that if we are continuing to build that amount of the power plant while we are recognizing the growing the reduction of the demand, there will be a lot of waste on this point of view. So at this point, that what I could also thinking that it needs to be re-evaluated, it needs to be redesigning, because whatever the assumptions being injected before is no longer valid today. It's not only because the economic, the pandemic that we have is growing demands, but also to some context, I think that's going to be with a lot of technology changing. What is being assumed expensive before, it's totally different right now. I mean, it's going to be this is the opportunity. I'm not saying that okay, let's government just change the target again, but this is to rethinking that going to be maybe 35 gigawatt. I mean, it's going to be from the national demand, or in IAS we also do the projection of modeling. Indonesia might not need to that amount of the capacity, because the energy efficiency program in Indonesia is also very good. That's allowing and so it needs to redefine it. What is will become a priority to fulfill their target, and then to some context is where we can push the renewable energy. Then of course there is a cost that need to be borne at this point, but in the longer term it will save cost us a lot. I'm sorry, it's not really properly your question, Mr. Ricky, but thank you very much.
Yeah, I think thank you, Mr. Benny. I think for the next question from okay, sorry. Okay, now one more question to Mr. Benny from Renner 3 ITB. Many of the ASEAN countries has already connected their power grid through APG, but Indonesia still don't have a concrete plan to connect our grids to the APG. Why Indonesia haven't joined the APG? And when we do join APG, how will it affect our tariff dasar listrik and PLN and also IPP owned power plants? Thank you. So you have another question.
Thank you again. Hello, Pak Reynald. Thank you for the question. First, Indonesia is already joining the APG. In fact, Indonesia through PLN actually the founding father of this APG concept. And the secretariat. So we have what we call it Papua Head of Authority Utilization. So it's kind of the association of all the utility state-owned company in ASEAN who are in charge about the APG, like PLN in Indonesia or TNB in Malaysia or IGAT in Thailand, who are in charge of this APG powers. So Indonesia actually is very supportive of this APG. It's PLN the head now. So but there are several issues that we are facing. One is the geographical constraint. Different with what the countries in the Mekong area like Thailand, Malaysia, or Laos, Vietnam, Myanmar, they are in one single piece island where the connection is more possible for them. So if you see the map that I showed earlier, is that area is so many interconnection grid that we have among the countries. Different with Indonesia is also same case with the Philippines who are far away. That's very challenging that geographical Indonesia become a constraint that we have. But nevertheless, we have we have the plan is to having connected between Sumatra and Peninsular Malaysia. So this is the discussion that we have between the PLN Indonesia side, the ministry, and also TNB that could be. Because it's also a very good connection that can be demand profile is different in the Sumatra that our demand is more on during the night, but in Malaysia the demand during the day. So it's a good combination on that one. The discussion is ongoing, but again, it's also if we are trying to connect it and then it will be undersea cable. This is like the cost that we are considering. I mean, the considering by both parties is still a very challenging. In today's economic calculation. But in the another side, in the Kalimantan is also already connected. I mentioned before, there are some connection on the ASEAN power grid in the Kalimantan with the Sabah and Sarawak, and that some context that even the hydro power plant is really coming from Indonesia, and that's being connected to the transmission that we have in Sabah and Sarawak, generated that way, or in another part that where Indonesia is being connected, they get electricity from the Sabah and Sarawak to the people in that border area because it's very difficult, very expensive to bring the electricity from the downside of the Kalimantan. So that's what happened, but again, it's also the discussion will also affect. But I mean, once you are connected, there are some. The market, the price will be discussing on the market price, which is where Indonesia is currently have a different market structures. We have a subsidies price, so that at some point people will be asking also if we are selling the electricity to Malaysia, is that the same price that we are paying right now? It's a subsidies or a different price. So a different market structure is also put a challenge for this electric interconnection. But the IPPs also have opportunity to grow on this one. I take one example in Thailand, and then we have a number of the IPP in Laos that are generating the electricity to Thailand. So this is an opportunity for the IPP to be part of this mega project ASEAN power plant project. But again, Indonesia was geographical is our main constraint. We are not really connected with all of the other countries, and undersea cables is at some point is still very expensive at the current situation. Maybe in the coming future it will be different games. But this is among the challenge that we have in APG and Indonesia role. Thank you.
Thank you very much, Mr. Benny Suryadi. Okay, big apologize to ladies and gentlemen. Finally, we come to the end of presentation. We would like to say thank again for all the presenters for their informative and interesting talk, and to audience for your active participation. Hopefully, the presentation will be beneficial for everybody. Thank you for your attention again. But before we leave the room, can we make a photo session, please? So I hope everybody can show up the face. Riva, can you take the photo, please?
Yeah, sure. I'll take the photo shoot. So.
Main lampu mah. Lampu.
Okay, I'll take it. 1, 2, 3, cheese. Okay, half done.
Okay, thank you very much, Riva. Thank you very much to our presenter, and thank you very much to all of audience in this conference. Apologize from me as a moderator, and I would like to say good afternoon. Assalamualaikum warahmatullahi wabarakatuh. See you in the next occasion.
Thank you.
Waalaikumsalam
warahmatullahi wabarakatuh. Terima kasih banyak Pak Dr. Taufik, Kolonel Yani, dan Pak Bambang. Terima kasih banyak.
Terima kasih Pak
Saya
Benny.
terus silaturahmi kolaborasi Pak.
Siap.
Salam.
Izin saya tinggalkan ruangan ini. Terima kasih banyak.
Bye-bye.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, dear all speakers and all attendants. Can you hear my voice correctly or clearly?
Waalaikumsalam warahmatullahi wabarakatuh. Yes, I can hear.
Okay, before we begin our session for our presentation, I would like to welcome all of you to the session. My name is Ahmad Hussein Siregar from Universitas Sumatera Utara, and I'm here to moderate 4 presentations in the area of energy security and defense. Now, I would like to explain a bit about our session. We will hear 4 interesting presentations from various speakers. Each presenter will have around 10 minutes to deliver their presentations. After all 4 presentations, I will allocate the remaining time for the speakers to answer the questions from the attendants. So, if you have questions, you can write down your questions in chat room, or you may also directly ask the presenter after the last speech. Now, we will hear the first presentation, which will be conducted by Mr. Sidik Permana. Are you already here?
Excuse me, Mr. Ahmad. I will presentate this presentation.
Okay, Ms.
Nuri.
Trianti.
Yes.
Okay, Ms. Nuri.
Yes.
Okay. Ms. Nuri is also it's from Department of Physics, Faculty of Mathematics and Natural Sciences, Institut Teknologi Bandung.
Right.
It's about how the potential contribution from nuclear energy to secure our electricity demand. Is that right?
That's right.
Okay, a very interesting topic, I say. So, Ms. Nuri, the floor is yours.
Pardon, for the slide, I shared the screen by myself.
I think you can do that. Maybe
right.
the host or the organizer can.
All right.
Yeah. Excuse me, Ms. Nuri. Maybe you could unmute your mic.
Excuse me. Okay. Can you see my presentation file?
Yeah, I can see it.
All right. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Good afternoon, ladies and gentlemen. Thank you, Mr. Chairman, for the opportunity today to presenting our study. I am Nuri Trianti. We are from Nuclear Physics and Biophysics Research Division, ITB. Today, I would like to present the study entitled Nuclear Energy Contribution Potential to Secure Electricity Demands with Low Carbon Emission and Low Risk of Power Plant in Indonesia. Here is the outline of our presentation. First is the introduction, continue with the section of new and renewable energy potential in Indonesia, the nuclear energy resource and the potential in Indonesia, and then the nuclear energy potential for electricity supply based on capacity factor and base load approaches in Indonesia. And last is the recommendation. I would start with the introduction section. The government of Indonesia shifted the paradigm related to energy, in which the energy considered as foreign exchange reversed in the past. Currently, the government of Indonesia is considering energy as the capital of developed the country. The shifted paradigm reflected the presidential decree of the Republic Indonesia and government regulation. According to the new paradigm, the energy no longer considered as the source of foreign exchange. However, it invites that fundamental strength in many fields of domestic economic activity, which in turn could enhance the country's revenues. Therefore, national energy resource management towards sustainable development becomes an essential task for Indonesia to deal with. Nowadays, the fulfillment of Indonesia's energy demand still dominated by the non-renewable energy source, which originated from fossil energy. In terms of electricity generation, the data records show that among the 64.5 gigawatt installed capacity of electric power plant as of 2018, most of them fueled by fossil energy. Coal contributes to the highest energy mix, around 50%, followed by gas 29%, diesel 7%, and renewable energy about 14%. The data record implies the relative high dependency on fossil energy. Further, the utilization of fossil energy will remain the first option to fulfill the national energy demand in the future. In Rouen, it stated that the new and renewable energy should be utilized at least 31% by 2050. Further, the utilization of crude oil should be reduced to at most 29%. The utilization of natural gas shall be optimized to at least 24%, and coal will be a significant national energy source in the future if the shortage energy supply occurs. Okay, next. On the other hand, as one of the countries that signed the Paris Agreement and one of 164 countries who ratified it, Indonesia committed to reduce the greenhouse gas effect, in which required the consistent development of environmentally friendly energy source. One of the potential and prospective new energy source in Indonesia is nuclear energy. However, nuclear is not priority in the development of energy source, especially for future electricity generation. The nuclear power plant considered as one of the clean, safe, and long life energy source. The development countries, including United States, Japan, France, have been utilizing nuclear energy source for an extended period as the primary power plant in their country. Indonesia is a country with a large area, a large population, and increasing economic activity, need to consider nuclear as one of the energy source that will support and accelerate the national development in the future with the role as an environmentally friendly energy source. Okay, I will continue with the section of the new and renewable energy potential in Indonesia. The new and renewable energy, RE, is an alternative to the energy resource which commonly used to fulfill the energy demand. Indonesia has various new and renewable energy potential, for example, hydropower, geothermal, solar, ocean energy, wind, micro hydro, and biomass. The NRE potential, which in Indonesia has, is around 431,000 megawatt. However, the installed capacity was around 6,000 megawatt. This figure shows that the NRE potential in Indonesia is quite immense. We can see here the distribution of NRE potential in each province in Indonesia. The green one is the NRE potential, and the pink one is already installed. For more details, the data thousand megawatt, wind 60,000 megawatt, and Ocean Energy about 17,000 megawatt. Despite the considerable NRE potential, only small portion of the capacity which already utilized for electricity production. And this is the next. Sorry. This is the next section of regarding the nuclear energy resource and the potential in Indonesia. Nuclear is one of the energy sources that are environmentally friendly and has considerable power potential. Nuclear, together with hydropower, has become the backbone of low carbon energy source, replenishing globally around 3 low carbon energy sources in the world. In general, apart from being an environmentally friendly energy source, energy also has a significant economic impact because nuclear based on a power plant has a longer service life. Hence, they are cheaper to maintain so that they are financially more competitive than other energy sources. Now we are in the area of a fourth nuclear power generation, which will be safer, more sustainable, economical, and more proliferation resistant and physically secure. Indonesia is a country with a lot of mineral resources, has nuclear resources. For example, the potential of uranium and thorium, besides being discovered in Bangka Belitung Islands, uranium and thorium are also found in Bengkayang Regency, West Kalimantan, and in Seruyuan and Lamandau areas, Central Kalimantan, and also Mamuju Regency, West Sulawesi. Okay, this figure depicts the comparison of life cycle inventory result of the production of 1 kilowatt hour of electricity for essential air pollutant contributing to particulate matter exposure, the leading cause of health impact from air pollution. The emission of gas pollutant and particulate matter coming from the life cycle of the pressurized water reactor are much smaller than those from other energy sources. The coal-fired power plant released the highest amount of ammonia, nitrogen dioxide, and PM2.5 in their life cycle. So according to the Nuclear Energy Institute, the United States avoided more than 476 million metric tons of carbon dioxide emission in 2019. It also keeps the air clean by removing thousands of tons of harmful air pollutant each year that contribute to acid rain, smoke, lung cancer, cardiovascular disease, etc. Nuclear energy has several features compared to other energy sources. First, nuclear energy is relatively more environmentally friendly since nuclear fuel does not release greenhouse gases during the burning process. It releases the greenhouse gases only during the mining and the processing of nuclear fuel. However, the amount of the greenhouse gases emission, such as CO2, is relatively small compared to other fuel types, for example, oil, gas, or coal. This figure shows the comparison of CO2 emission release from the life cycle of power plant with various generation methods. CO2 emission of nuclear power plants are among the lowest of any electricity generation method, and on a life cycle basis are comparable with to wind, hydropower, and biomass. Life cycle emission of coal generation are 30 times greater than nuclear. By the assumption of CO2 emission per gigawatt hour presented in the previous slide, here we estimated the CO2 emission composition in a 1,000 gigawatt hour electric production from various energy resources. The fossil energy contribute about 93.7%, while the remainder contributed by new and renewable energy source. Next is by the increase of electric production, the projected amount of CO2 emission released from fossil energy will be also increasing significantly. Meanwhile, the projected contribution from new and renewable energy is much lower than emission contribution from fossil energy. And then here we can see the new and renewable energy and fossil energy. And then next, nuclear technology also produce minimal waste in their life cycle. Here is the schematic illustration focused on the energy density comparison between nuclear fuel and other kinds of fuel. Nuclear has a remarkably high energy density. One pellet, approximately the size of human index finger, of nuclear fuel produce energy equivalent to 1 ton of coal or 2.5 tons of firewood and equivalent of 17,000 cubic feet of natural gas. From the safety viewpoint, the nuclear power plant has the highest standard of safety on their operation. This figure compares the death rate from the primary energy source. The study considered deaths from accidents, such as the Chernobyl nuclear disaster, occupational accident in mining or power plant operation, and premature death from air pollution. As shows in this figure, the death rate from energy production per terawatt hours from brown coal and coal is much larger than nuclear. Nuclear energy is by far the safest energy source in this comparison. And in this study, we aimed to estimate the potential contribution of nuclear power plant to secure the electricity demand in Indonesia. There are two key factors included our estimation, namely the power plant capacity factor and base load. The installed power capacity is different from electricity production. Each power plant produces electricity for different level electricity production depends on capacity factor. The capacity factor of the various power plant was obtained from U.S. Energy Information Administration. And various energy resources have been used for electricity power generation, which has their own characteristics, such as the capacity factor and base load of electricity. Baseload electricity of power plants, as well as medium and peak load approach, are one of the electricity capacity supplies based on their capability to produce electricity from power plant operation and its stability of supply over time. As we can see here the table. The baseload approach for electricity supply in general can be categorized based on high capacity factors such as coal power plant, nuclear power plant, geothermal plant, and hydropower plant. The other power plant can be categorized as medium and peak load electricity. The figure shows that estimated electricity production of various power plants based on their capacity factor and baseload approaches. Each power plant produces electricity for different level electricity production in the same power capacity, or about 1,000 megawatt, depends on capacity factor. Yeah, this figure is regarding the estimation level of contribution of various electric power plant based on capacity factor and baseload approach. Capacity factor and baseload approaches can be utilized to estimate the contribution level for various energy resources as shown in previous table and chart. And this estimation values can be obtained by normalized electricity potential production, which is corresponding to capacity factor and categorization of base load factor. The normalized energy factor was used based on the same power capacity of each energy to a level of 1,000 megawatt. And by a conversion value process from power capacity to electricity production based on their energy properties of capacity factor. Base load assumptions, energy classification, as well as of transmission and distribution. Each electricity production from all energy resource tabulated as total electricity supply. And the total value of electricity production will be used as normalized value to be used to obtain the contribution level of each energy resource in percentage. So the coal power plant, nuclear power plant, hydropower, and geothermal are categorized as a baseload electric can supply more than 60%. And others can contribute to medium load and peak load electricity. Here, nuclear can contribute 25% of the total energy supply and followed by coal and hydropower power plants for 18% and 12% contribution respectively. When classified as fossil fuel resource contribution based
I
on
would
this
like to
approach.
inform you, Ms. Nuri, you have around 2 minutes for
all right.
the rest of the presentation.
Okay, I will be faster now. All right, here is the estimation level of the contribution. Okay, next I will move here. This figure is of the power plant of capacity and its electricity production. The correlation power plant capacity with electric production is obtained based on a 63% capacity factor and 10% loss of year electric production. I want to say that here we can see, for instance, 10,000 megawatt of power capacity will produce about 50 terawatt hour. And when it's required power capacity about 60,000 megawatt will produce about 280 terawatt hour. This estimated data can be utilized to predict when for the future electricity need. And then here this figure shows that the various power plant contribution to total electric production as a function of power capacity power plant. To obtain the total electricity production, various energy resource will contribute as energy mix approach. Here we can see as the figure. It shows that the nuclear power plant contributes the highest energy level in comparing to other resource, and it will be consistently increased with increasing energy demand. When the level of contribution is kept in a constant value to total electricity supply, and in this case, nuclear contribute to 25% of total electricity supply. Moreover, when the energy resource classified as NRE, the contribution will be more than 70% of the total electricity supply, and fossil fuel will be less than 30%. And then, okay, this is my last section of my presentation regarding the recommendation. Here are our recommendation. First, it is necessary to carry out detailed geological mapping and detailed geophysical surveys in area that have potential of thorium and uranium nuclear materials to obtain accurate information about the potential of these two materials, and more major volume calculation can be carried out. The second one is, as amended in 2014 National Energy Policy Can, regarding the priority direction for national energy development, it is suggested for Indonesia to consider to use of nuclear energy and mastering the technology of nuclear power plant to accelerate the achievement of the NRE energy mix by 2050. And the last, by adopting the capacity factor of the power plant and baseload power plant approach, new and renewable energy can contribute to more than 45% of total electricity supply as base load electricity contributor, including 25% of the nuclear contributor as one of an RE contributor. All right, that's all my presentation. Thank you very much for your attention.
Thank you for your speech, Ms. Nuri. Now we move to our next presentation with Mr. Yosi Ohira.
Yes,
Is that right?
I'm ready. Yeah.
Pardon?
Yes, I'm
Yosi Ohira.
ready.
Yeah.
Yes,
Okay.
yeah.
From Department of Engineering, Energi Mega Persada. That's right.
Yes, that's right.
Okay, this time we will hear about how a company could participate in supporting energy security through their employees by installing solar panel in rooftops of their house, I guess. Is that right, Mr. Yoshi? This is
That's right.
from employees, yeah?
Yes, that's right.
Okay, so it's now your turn, Mr. Yoshi, please.
Okay. Thank you. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. First of all, I would like to thank the organizer for inviting me to this event. My name is Yosi Ohira, and I am a practitioner of a national energy private company headquartered in Jakarta. Today, I will talk about how a large company can contribute to achieving the government target in the national energy mix, especially in achieving the use of solar energy. Hopefully, my presentation today can help all of us to see our potential more positively. Electrical energy is one of the most important basic needs in human life today, where almost all human activities are related to electrical energy. Unfortunately, the power generation system in Indonesia mostly uses fossil fuels as an energy source in producing electrical energy. Apart from decreasing reserve, the use of fossil energy also has an impact on the environment, especially the effect of global warming. To ensure energy sustainability and development, the government of Indonesia, through the National Energy Plan, or RUEN, targets the use of renewable energy by 23% by 2025. Okay. Solar energy is a renewable energy source that can be used easily and cheaply. Basically, solar panels need an open area and free from objects or shadows that block sunlight from hitting the panel. One solution for placing solar panels is the use of a building roof. Not only office buildings, rooftop solar panels can also be applied to the roof of private houses that are on grid with electricity from PLN. The household sector is one of the targets for implementing solar panels, which is the hope of the government of Indonesia in achieving the target of using renewable energy. Regulation of the Minister of Energy and Mineral Resources number 49 of 2018 regulates the use of rooftop solar power generation system by PLN consumers. Through this regulation, citizens can pay cheaper electricity bills through export-import electricity with PLN. In addition to providing opportunities for citizens to use environmentally friendly renewable energy, this government policy aims to increase the role of new and renewable energy in the national energy mix, accelerate the increased use of solar energy, and reduce greenhouse gas emission. The company's participation has contributed to achieving the national energy mix and accelerating the use of solar energy not only for production operation and office buildings, but can also contribute by involving employees to install rooftop solar panels in their homes. PLN electricity customers are grouped based on household customers, industrial customers, business customers, social customers, government office building customer, and public street lighting. Based on the PLN Electricity Supply Business Plan, or REUPTL, for 2019 until 2028, household customers are the largest group. As previously explained, it is possible to achieve the energy mix target by accelerating the utilization of solar energy using rooftop solar panels in households because of the large amount of consumption. How does the company play a role in achieving the energy mix target? Indonesia has many companies from large scale to household scale. The Indonesian Central Bureau of Statistics, or BPS, recorded the number of large and medium scale companies. In this study, we are focused on the large and medium industry groups only. As a reference, the object of study is an Indonesian oil and gas company that has more than 100 employees. Overall, the number of employees working in large and medium industries in Indonesia can be seen in the following graph. Assuming that each employee in large and medium-sized industry already owns their own house and it is a PLN customer with installed power at the R1 tariff, or 2,200 volt ampere. So the potential for rooftop solar panels can reach 13 gigawatt peak. Therefore, in order to increase the use of renewable energy, especially solar energy, the company can conduct a campaign for all employees to take advantage of the solar panel system, which can be integrated with the PLN electricity network. For example, by conducting education that households are one of the users of electrical energy who use a lot of electronic equipment, but energy consumption among households is considered wasteful. Providing awareness that in consuming electrical energy that is not good is one of the causes of the high level of waste in household energy use. And giving an overview of the benefit that employees get for the installation of solar rooftop panels is that the electrical energy produced can be replaced the PLN function during the day. Besides that, excess power from the solar panel can also be exported to the PLN network through the export-import meters, or EXIM meters, where electrical energy which is exported to the PLN network can be used as a deduction for electricity bills. The company, as an initiator, can develop a collective installation scheme for rooftop solar panel for its employees with an interest-free installment scheme. Installments are paid by employees through salaries, which are deducted every month as much as the agreement between the company and the employee. Companies must consider the ability of their employees for the length of the installment period. And the total installation target is also determined by the company's ability to funding the purchase and installation cost of the solar rooftop panels. In essence, the program can be carried out if it doesn't interfere the company cash flow because the company will be funding in advance, or the employees who pay installments to the company. PT Energi Mega Persada is one of the large companies in Indonesia which is engaged in the energy sector, initiating the collective installation of rooftop solar panels with an installment scheme, with the assumption that the average capacity of the rooftop solar panels that will be installed in each house of the interested employee is 2 kilowatt peak, and the price range from 40 million rupiah, including the EXIM meter, then the employee makes installments of around 1.5 million rupiah for 24 months, or 1.1 million rupiah per month for 36 months. The program is run in stages. For example, with a capacity of 200 kilowatt peak per year, with a capacity of 200 kilowatt peak per year, the company requires capital at one stage of 3.4 billion rupiah for the 24-month installment scheme and 3.6 billion rupiah for 36-month installment scheme. The assumption that the installation period of the rooftop solar panel is 18 houses per month, that is, each house requires 5 days of installation, including team mobilization and demobilization, and the number of teams is 3 teams. The total time for completion can be done within 7 months. In order not to interfere with the company's cash flow, the payment system to supplier is based on work progress, and installments from employees are started after the solar rooftop panel is installed on the roof of each house. So based on the data from the BPS, Indonesia has more than 33,000 large and medium companies. If each company has a collective installation program for rooftop solar panels of 200 kilowatt peak, then within 7 months, the utilization of solar energy will reach 6.72 gigawatt peak. Meanwhile, the Indonesian government is targeting the use of solar energy for the national energy mix in 2025 at 6.5 gigawatt. Therefore, involving companies and providing support to them can be one way to achieve the target of using solar energy in Indonesia. Conclusion, by realizing a collective rooftop solar panel installation program for employee rooftops with an interest-free installment system for 24 to 36 months that is deducted from wages through the payroll system, taking into account the company's ability to fund this program, and assuming a total capacity of 200 kilowatt peak at each company, or it's about around 100 employees' houses, the maximum cost impact for the company is around 3.6 billion rupiah. If this program can be implemented simultaneously by all large and medium-sized companies in Indonesia, the potential for achieving solar energy use within 7 months could reach 6.72 gigawatt peak. And then thank you for the attention and time. That's all the explanation I can give. Hopefully it can be benefit for us. Thank you.
Okay, thank you for your interesting presentation, Mr. Yoshihiro. Now we are continue to third presentation. It's about management of sustainable resources in supporting Semangke SE as eco-industrial park. The speech will be presented by Ms. Nobria Husni. Yeah, okay. That's already there. It's from Badan Penelitian dan Pengembangan Sumatera Utara.
Yes, correct.
Okay, Ms. Nobria Husni, the floor is yours.
Thank you, Bapak Ahmad Hussein, as a chairman. Okay, let me share my screen. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon to distinguished participant, presenter, moderator, and committee of Medan International Conference on Energy and Sustainability, or MICES 2020. First of all, I would like to introduce myself. My name is Nobria Husni. I'm a researcher of R&D Agency of North Sumatra. On this occasion, I would like to present a paper titled sustainable resources management to support Semangke Special Economic Zone as an eco-industrial park. The Semangke Special Economic Zone, later on we call SEZ, is a business development approach in the form of a particular area for industrial center based on oil palm and rubber base. The uniqueness of Semangke SEZ is its location in the agro-based raw material center, which is not owned by other industrial estate in Indonesia. Semangke SEZ is one of the project of MP3AE, or Master Plan for the Acceleration and Expansion of Indonesian Economic Development, and officially opened in 2015 by President Joko Widodo. In 2020, the palm oil industry is still a significant activity in the Semangke SEZ. However, the area also for supporting businesses such as logistics, energy, electronics, various industries, and tourism. However, until to date, there are only 3 tenants operated until the end of 2018, and one of the problem is the lack of energy source. Energy needs are necessary to support the development of the region. However, the ability of the region to provide energy independently until now is only the use of oil palm empty fruit bunches, which is used by the palm oil mill. So the more comprehensive analysis is needed to meet the energy needs of the Semangke SEZ as a whole, so that the area's operation can proceed as expected. So the research aim is to formulating renewable energy management effort to support sustainability of Semangke SEZ as an eco-industrial park. Method of this research, location of the research is in Semangke SEZ in Simalungun Regency with area of 1.9 thousand acres and expected to be able to absorb 83.3 thousand people by 2031. The data collected is primary and secondary data. Primary data is obtained from interview and document from informant, while secondary data is collected from previous research reports, articles from relevant journal, and government regulation. Informant of the research are the managers of Semangke SEZ, and then the research use qualitative approach and then analyze descriptively. Result and discussion. There are 3 managers of Semangke SEZ, namely the administrator, secondly the PT PN3, and the third one the PT Kinra. The administrator has the duty to carrying out monitoring and control activities with the assistance of technical personnel from the Office of the Environment, Labor Office, and the Department of Special Planning and Settlement of the Government of Simalungun Regency. While PT PN3 is the owner of oil palm and rubber plantation land, which is currently as Semangke SEZ. PT PN3 also established the development and management body of the Semangke SEZ to the decree of the Simalungun region. They are also a building body and has land management right covering an area of 1.9 thousand acres under the decree of head of the Republic of Indonesia National Land Agency. While PT Kinra or Kawasan Industri Nusantara is a business entity owned by PT PN3 with business in the marketing and management services of Semangke SEZ. The establishment of this PT Kinra is aimed to optimizing the utilization of the company's power so that it produces goods and or services that are high quality and highly competitive to obtain or pursue profits to increase value following the company's principle. Institutionally, PT Kinra is under the Semangke SEZ administrator in reporting and developing investment in Semangke SEZ. During 2060 to 2021, PT PN3 planned to build 640 acre out of 1.9 thousand acre. But until end of 2080, there is only 212 acre developed by tenant, or only 1/3 from the target in the second phase of development. For the tenant, there are only 3 tenants in SE Semangke per end of 2018. There are Semangke Palm Oil Mill, Semangke Kernel Oil Factory, and Unilever Oleochemical Indonesia. Compared to the width of area 1,900 acre, carrying capacity of Semangke SEZ is at tolerant level and have not affected the environmental negatively. For the electricity, there are 2 sources of electricity in Semangke SEZ. One is from PT PLN with capacity 150 kilovolt, while for the biomass energy is produced by palm oil mill with the capacity 2 times 3.5 megawatt and used only for the need of palm oil mill itself. There are a gas pipeline in Semangke SEZ, however, it is not recommended because the distribution is quite a bit hard and the price is high. Based on the available resource in Semangke SEZ, there are several alternative resources can be generated into electricity energy. In example, empty fruit bunches, cells, fiber, palm oil waste, and domestic waste. Realizing that Semangke is a particular area of industrial center based on oil palm and rubber, there will be abundance of palm oil waste that can be converted into renewable energy. To produce high energy source can be through torrefaction process with the raw material from the oil palm waste. Okay, this figure is shown the torrefaction process, which is a slow rotting process to remove oxygen and produce the final result in solid form. So the torrefaction process, the raw material can be from empty fruit bunches, mesocarp from palm kernel, from oil palm trend or oil palm trunk. And then the stage is preheat, pre-drying at temperature 200 to 300 degrees Celsius. And then the advantage of using the torrefaction process are reducing the fuel consumption, improve waste management system, reduce contamination to the environment, and increase energy source. For the waste management, there are several ways in SE Semangke. For the liquid waste, is managed by PT Kinra, while for the palm oil liquid waste is managed by palm oil mills. PT Kinra manages all liquid waste in the Semangke SEZ except liquid from palm oil mill because they processed by themselves. Liquid waste management at PT Kinra is adjusted to UKL-UPL document, then flow to the river body. At the same time, management of domestic solid waste is done conventionally by providing garbage truck to transport waste to the landfill. Sadly, until 2020, Semangke SEZ does not have land that can be used as a landfill. Therefore, an alternative of domestic waste management is needed to avoid decreasing of environmental carrying capacity. Based on this fact, there are potential renewable energy source from domestic solid waste to use as renewable energy source. In general, activities at Semangke SEZ have implemented the philosophy of eco-industrial park philosophy because they have used the symbiosis industry approach to achieve regional competitive advantage. The symbiosis industry concept that has been running at the Semangke SEZ, namely, for example, palm oil mill produce kernel and then used by kernel factory to create crude palm kernel oil, and then used by Unilever Oleochemical Indonesia as consumer good. Also, for example, the liquid waste from palm oil mill used by biogas power generation to generate electricity. Discussion of this paper, along with the research of Ansori M. et al. In 2014, conclude that palm oil biomass can be converted into energy, where the research taking sample at the palm oil mill in North Sumatra, where 3 tons of empty fruit bunches can produce electricity with a power of 20 to 35 megawatt. And then research of Sukiran MA et al. In 2017 conclude that optimization of palm oil waste as source of biomass energy can be through torrefaction, so that the energy could increase. Also, the research of Wang S. et al. In 2019 regarding eco-industrial philosophy and symbiosis industry, where the SEC Semangke has applied the symbiosis industry. And last but not least, research of Husni et al. In 2019 that suggests sustainability variables to use in environmental performance assessment, because most of managers of Semangke SEZ understood that sustainability variables should be used in environmental performance assessment to support the philosophy of eco-industrial park. Conclusion of this research, Semangke SEZ has implemented the principle of the eco-industrial park and can be developed as planned. And the recommendation is alternative fulfillment of electrical energy needs in Semangke SEZ come from biomass power energy, namely shells, empty fruit bunches, palm oil mill liquid waste, and domestic solid waste. The use of biomass energy as an alternative to electrical energy must be done as early as possible before the area operates optimally and the demand for electrical energy is increasing. That's all my presentation. Thank you for all the attention. Assalamualaikum warahmatullahi wabarakatuh and good afternoon.
Right. Thank you, Ms. Nobria Husni, for your presentation. For the last presentation, I would like to give the time for Ms. Here is Ms. Ayu Nirmalasari or Ms. Reni or Diki, Mr. Diki Setian Diningrat. Who will deliver the speech from the 4 presentations. It's about the anti-meningitis agent, potentially Cysium cumini essential oil by ZCMS. Miss Ayu Nirmalasari, are you there? Or Miss Rene Sylvia Nastion? Or Mr. Diki Setiadiningrat? Okay, I've got latest information that the presenter for all the presenter are not in the room, main room or this room. So I think we are going to have our time for questions from our attendants. If you have questions, you may directly ask the presenters by unmuting your mic. Okay. There is question from Ms. Nobria Husni. This is for Mr. Yossi. How much the price for installation of solar panel for private houses? Can it be done by customer itself? Thank you. So, Mr. Yossi? Mr. Yossi Ohira?
Okay. Thank you for the question, Ms. Nobria Husni. How much the price of for the installation of the solar panel for private house? There are many various the price of the solar panels. So basically, we are as a company looking for a supplier. There are three candidates for supplier. The cheaper we get the price for 1.5 kilowatt peak is around 29 million rupiah, including the net metering or export-import matter. And for the 2 kilowatt peak is about 40 million rupiah. That's all include the net metering. So can it be done by customer itself? I think for the installation solar panel, it can be done for the customer itself, but some of the knowledge about the panel or an inverter or about the DC cables. So maybe it's better than we give the supplier or installer to install to our home. Maybe that's my explanation. Thank you.
Okay, thank you, Ms. Yoshi, for your answers. If you still have questions, you can ask. You may directly unmute your mic. So while we are waiting for next questions, I think I would like to ask Mr. Sidik and Ms. Nuri Trianti, Ms. Nuri Trianti. Ms. Nuri Trianti from ITB.
Yes, Mr. Ahmad Hussein Senegal, please.
Okay. In your slideshow, it tells that date rate it's only 0.07, if I'm not wrong. So this is an interesting data. The first question is this data here from where does this data come from? I mean, is from all over the world or just from some countries? And the second is that for many people, including me, the nuclear energy is something that looks like how do you say it? Frightening solution. I mean, because we have seen some accidents from nuclear plants or something like that. So how this date rate is only 0.07 while the others have 30 or more date rate from coal or fossil fuel.
All right, thank you very much, Mr. Ahmad. So I showed before that from the safety viewpoint, the nuclear power plant has the highest standard of safety on their operation. So the figure I shows that on the slides compare the death rates. This is the we compare the data from, for example, for nuclear, such as the Chernobyl nuclear disaster, and then the occupational accident in mining or power plant operation. So we take all the data. So that's so we can get the data, the conclusion that nuclear power, the death rate from by nuclear power plant is very, very small. That as you said, that nuclear is very, very for many people maybe is a kind of big things. Maybe many people hear when someone hear nuclear, maybe they just imagine the bomb or something like that. But actually, in the nuclear power plant reactor, we have very, very high standard of safety of the operation itself. So and also I shows that in this generation we use the fourth generation of nuclear power plant, which is have very, very high safety procedure. So yeah, the fourth nuclear power generation will be safer, more sustainable, economical, and more proliferation resistant, and basically, of course, will be secure. Yeah, that's all my question, my explanation about the death rate.
Okay, thank you, Ms. Nuri. I hope it will maybe decrease my worry about this nuclear. We have already now question from Mr. Fikri Miftahul Siddiq, I think. Yeah. Dear Ms. Yossi, how much the energy can result from one house and it full fill daily need of the house, or if the electricity produced exceed, can it sell to PLN as a profitable income for everyone whose house producing? Okay, I think it's about how much energy we could get from installing the respective solar panel, and if we have more electricity than we need from the solar panel, can we sell that? Can we sell the electricity? Mr. Yossi?
Okay. Thank you for the question. From our experience, the energy produced from the photovoltaics or solar panels depends on the solar irradiation at that moment. So if any cloud, so the energy will down, and the PV power out is low from the produce. So okay, from our experience, the saving from solar panels is around 20% of the electricity bills. So we have two places in our operation in the field, in oil and gas area, which is before we install the solar panels, the bills can reach up to the 7 million rupiah per month. So we install the solar panels about 15 kilowatt peak. The bills reduce until 5 million rupiah. So there are 2 million rupiah saving from the solar panel. So the saving, not including the export import. Export import will appear if there are excess power from the solar panels can also and our installation installed with export import method. So the electrical energy from the solar panel will be exported to the PLN network. I think that's my explanation.
So, Mr. Yosi, if we assume that the day is bright, I mean the peak, the maximum capacity of the one installation, you said that it's about 29 or 30 million. Can this one installation or one installation fulfill daily needs of maybe from one house of a small family?
In our experience, their production capability from the solar panel is about 18% from the total capacity, which is if we install 1 kilowatt peak, so the maximum production is about 0.8 kilowatt. Maybe.
Okay. So it depends how big our needs of electricity, I think, yeah. Okay. Next question. I would like to ask. We have still time here. I would like to ask Ms. Nurriya Husni. You said here in your slideshow that the SEZ obtained biomass from palm oil, bunches, palm oil, empty fruit and waste, and domestic solid waste. Is there any biomass sources that that is being used or will be used by the Seimangke SEZ, or only the palm oil, from the palm oil?
Thank you for the question. So until now, the biomass that already used, already used in the SE Seimangke is the COD from the palm oil mill. There is a waste on the pond, and they convert the gas from the COD into electricity energy.
So that's from the biomass to gas.
Yeah, the methane gas from the COD convert to energy by the biomass generator.
So only right now only from palm oil, yeah?
Yeah, only from the palm oil.
Okay, thank you, Ms. Husni.
My pleasure.
Okay. Is there any more questions from our attendants? Yeah, Ms. Fitriani. Okay. From that's from Mr. Yosi Ohira. Ms. Fitriani Tupa, do you have question?
Sorry, I don't have any question.
Okay, I thought you have any question. Okay, Miss Rifa, the NCL.
Yes, sir.
Do we have a photo session here? Because I think there is no more question. This is from me, Mr. Yosi. I think this the explanation for Mr.
Okay.
Fikri.
Yes. I think if we have not question again, so we can take the photo shoot maybe.
Okay.
Okay.
Yeah, for all presenters and attendants, if you could show your video, share your video. We will take
Mr.
a photo
Chairman?
shoot. Yeah.
Can I take the photo shoot when I said 1, 2, 3, 4?
Okay.
Okay, ready? 1, 2, 3, cheese. Once again, please. Okay. 1, 2, 3, cheese. Yes, half done.
Okay, I think that's all the presentations we have listened. So I would like to thank to all presenters from ITB, from Badan Penelitian dan Pengembangan Provinsi Sumatera Utara, and from one is from from Energi Mega Persada. And also I would like to thank to all our participants for your questions and for your active contribution in this session. I am Ahmad Siregar. Say goodbye to you all. Thank you. Assalamualaikum warahmatullahi wabarakatuh. Good evening for you all.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you very much, Mr. Ahmad.
Thank you. Thank you very much. Thank you very much all.
Established in 1920 with the name Technische Hogeschool Bandung, Institut Teknologi Bandung is the oldest technical university in Indonesia. The 3rd of July 2020 is marked as Institut Teknologi Bandung's 1-century existence. The establishment of this long-established institution is recorded in history as the founding of Indonesian technical higher education and the pioneer in the advancement of science and technology in Indonesia. Located in Bandung, West Java, Indonesia, precisely on Ganesha Street number 10, ITB currently has 12 faculties, 29 undergraduate programs, 52 master's programs, 26 doctoral programs, and 2 professional programs. Other than the campus site located in Ganesha, ITB's campuses are also located in Jatinangor and Cirebon. 39 programs have been international accredited from accreditation boards around the world, namely from United States of America, ASEAN, Germany, Japan, the United Kingdom, South Korea, and the number of accredited programs is expected to increase in the near future. ITB has been developing its cutting-edge research through the 102 research groups from 12 faculties and schools, 24 centers, 7 research centers, and 5 centers of excellence. To date, ITB has also established 104 startups, 315 intellectual property rights, and 137 innovations. In the spirit of In Harmonia Progressio, ITB alumni have worked and excelled in various fields and sectors. For instance, Insinyur Soekarno as the first president of the Republic of Indonesia, B.J. Habibie as the 3rd president, Iskandar Ali Shahbana as the father of the communication system in Indonesia.
Institut Teknologi Bandung is an adaptive learning organization, providing ideas and experiences, critical and visionary thoughts, accompanied by attitudes that uphold academic freedom in scientific and cultural diversity. In our 100-year journey, ITB has played a significant role in solving local problems while improving its capacity to compete globally. We are keen on continuously improving the quality of education, research, and community services, fostering our role as a locally relevant and globally respected university.
Established in 1920 with the name Technische Hogeschool te Bandung, Institut Teknologi Bandung is the oldest technical university in Indonesia. The 3rd of July 2020 is marked as Institut Teknologi Bandung's 1-century existence. The establishment of this long-established institution is recorded in history as the founding of Indonesian technical higher education and the pioneer in the advancement of science and technology in Indonesia. Located in Bandung, West Java, Indonesia, precisely on Ganesha Street number 10, ITB currently has 12 faculties, 29 undergraduate programs, 52 master's programs, 26 doctoral programs, and 2 professional programs. Other than the campus site located in Ganesha, ITB's campuses are also located in Jatinangor and Cirebon. 39 programs have been international accredited from accreditation boards around the world, namely from United States of America, ASEAN, Germany, Japan, United Kingdom, South Korea, and the number of accredited programs is expected to increase in the near future. ITB has been developing its cutting-edge research through the 102 research groups from 12 faculties and schools, 24 centers, 7 research centers, and 5 centers of excellence. To date, ITB has also established 104 startups, 315 intellectual property rights, and 137 innovations. In the spirit of In Harmonia Progressio, ITB alumni have worked and excelled in various fields and sectors, For instance, Insinyur Soekarno as the first president of the Republic of Indonesia, B.J. Habibie as the third president, Iskandar Ali Syahbana as the father of the communication system in Indonesia.
Institut Teknologi Bandung is an adaptive learning organization, providing ideas and experiences, critical and visionary thoughts, accompanied by attitudes that uphold academic freedom in scientific and cultural diversity. In our 100-year journey, ITB has played a significant role in solving local problems while improving its capacity to compete globally. We are keen on continuously improving the quality of education, research, and community services, fostering our role as a locally relevant and globally respected university.
Established in 1920 with the name Technische Hogeschool Bandung, Institut Teknologi Bandung is the oldest technical university in Indonesia. The 3rd of July 2020 is marked as Institut Teknologi Bandung's 1-century existence. The establishment of this long-established institution Established in 1920 with the name Teknische Hogeschool Bandung, Institut Teknologi Bandung is the oldest technical university in Indonesia. The 3rd of July 2020 is marked as Institut Teknologi Bandung's one-century existence. The establishment of this long-established institution is recorded in history as the founding of Indonesian technical higher education and the pioneer in the advancement of science and technology in Indonesia. Located in Bandung, West Java, Indonesia, precisely on Ganesha Street number 10, ITB currently has 12 faculties, 29 undergraduate programs, 52 master's programs, 26 doctoral programs, and 2 professional programs. Other than the campus site located in Ganesha, ITB's campuses are also located in Jatinangor and Cirebon. 39 programs have been international accredited from accreditation boards around the world, namely from the United States of America, ASEAN, Germany, Japan, the United Kingdom, South Korea, and the number of accredited programs is expected to increase in the near future. ITB has been developing its cutting-edge research through the 102 research groups from 12 faculties and schools, 24 centers, 7 research centers, and 5 centers of excellence. To date, ITB has also established 104 startups, 315 intellectual property rights, and 137 innovations. In the spirit of In Harmonia Progressio, ITB alumni have worked and excelled in various fields and sectors. For instance, Insinyur Soekarno as the first President of the Republic of Indonesia, B.J. Habibie as the 3rd President, Iskandar Ali Shahbana as the father of the communication system in Indonesia.
Institut Teknologi Bandung is an adaptive learning organization, providing ideas and experiences, critical and visionary thoughts, accompanied by attitudes that uphold academic freedom in scientific and cultural diversity. In our 100-year journey, ITB has played a significant role in solving local problems while improving its capacity to compete globally. We are keen on continuously improving the quality of education, research, and community services, fostering our role as a locally relevant and globally respected university.
Simanindo sebagai area yang khas akan budaya Toba. Hadir sejak zaman Kerajaan Batak, akan hadir dengan peningkatan dan perlindungan performa Huta Batak. Panguruan baru akan menjadi sinergi antara alam dan wisata. Infrastruktur dengan desain berdasarkan nilai kearifan lokal untuk kemudahan perjalanan di Danau Toba yang berkarakter budaya. Sebuah perencanaan berdasar selebrasi alam dan wisata. Balige hadir dengan tema wisata urban heritage. menghadirkan proporsi bangunan, jalan, dan pedestrian energi dari kegiatan. Pariwisata yang ramah bagi masyarakat dan penyandang disabilitas. Muara sebagai destinasi wisata Toba yang penuh bingkai pemandangan. Bukit dramatis menuju danau alam indah Muara menjadi sapaan hangat setiap panoramanya. Berfokus pada peningkatan destinasi alam dan kualitas kampung budayanya. Merek baru hadir dengan tema destinasi Nature Eco. Wisata di mana Anda bisa menikmati keunikan alam Toba dengan fasilitas yang bersanding dengan alam serta budayanya. Dan diikuti oleh Toba Caldera Resort sebagai destinasi premium, pionir terhadap kemajuan pariwisata Danau Toba dengan fasilitas berkelas dunia, menjadikannya magnet pariwisata dunia dengan fasilitas golf di tepi Bukit Danau, dilengkapi fasilitas kesehatan bertaraf internasional, hotel dan resort berbintang 4 dan 5 berkelas dunia, dengan total kamar yang tidak kurang dari 3.000 ruang untuk menikmati rona alam yang inspiratif khas Danau Toba. Menjadi tuan rumah event dunia di rona alam khas Caldera. Di alam Toba dengan pengalaman mengagumkan. Selebrasi keindahan alam, budaya, dan wisata. Toba Caldera Resort sebagai pionir wisata kelas dunia menyajikan petualangan penuh pengalaman dan kebahagiaan akan warisan budaya di alam surga kaldera dunia di tanah suku Batak.
Dear distinguished guests, speakers, and participants, thank you very much for staying with us online until our very last session for today. And also thank you for joining the two-day Medan International Conference on Energy and Sustainability, MICS 2020. We hope that you found the conference informative and worthwhile. Later on, the conference videos are also available on IAITB Sumut YouTube channel. And per the speaker's consent, we will also share the documents via the MICS 2020 website. The website is 100 tahun ITB-ia-itbsumut.info that will also share with you in the chat. Now, it is the time to announce the best paper presenters. MICS 2020 have received a number of papers from August 3rd until 18 October 2020. Thank you for all participants who have submitted their papers. All accepted full papers will be published in Proceeding indexed by Scopus, and 5 best paper presenters will receive cash awards. To announce the winner, we'd like to invite we will wait for a few minutes on the deliberation. Okay, continuing to the event. To announce the winner, we'd like to invite Mr. Zaid Perdana Nasution, PhD, the chairman of MICS 2020 Organizing Committee, behalf of the MICS 2020 Committee. Ladies and gentlemen, once again, Mr. Zaid Perdana Nasution, PhD, the chairman of MICS 2020 Organizing Committee.
Hello? Is it clear? Can you hear my voice clear? Okay, all right. Thank you very much. Thank you, Dian. Okay, hello everyone.
I think we have reached almost the end of our conference for 2 day conferences and for 2 day conference, and right now it's time for us to tell about one of the program that I think you have been waiting for. It is about announcing the, let's say, best paper presenters. We have select and with several criteria for 5 best paper presenters. I think before I tell you about the winner, I will let you know firstly about the criteria that we have. We make this the criteria into at least 2 main criteria. First about the paper, secondly about the presentation. The paper criteria is divided into 3. The plagiarism, and then the Grammarly by using Grammarly, and then the score by the reviewer about the paper, and then the presentation. Criteria that used by the reviewer, it's quite many actually, about the relevance of the paper with the topics, how the author describe the theoretical background, and then what is the research purpose, something like that, about the literature review, and then methodology, and then conclusion, something like that. About the presentation, there are several other criteria about how interesting the slides, how the visual presentation of the slides, and then about the engagement with the audience, and then about the timekeeper, something like that. Just so how the presenter can finish the presentation on time, something like that. So after making several scoring by using those kind of criteria that we have made, and then we have decided there are 5 best paper presenters for this conference. Number 1. Okay, sorry. My friend suggests me to announce it from number 5 first. All right, number 5 with the paper code EES 1012 under the name Eric Eswandi et al. And then paper with the code number NRE 2008 under the name Mr. Haryadi. I guess he's from House of Representatives, if I'm not mistaken. Oh yeah, Mr. Eric Iswandi is from Defense University, Indonesia Defense University. Yes, and then number 3, paper with the code number on NRE 2018 under the name Harlia et al. I guess the author is from University of Pajajaran. Yes. Number 2, paper with the code number NRE 2027, Mr. Dwi Haryanto. I guess he's from ITB and ITERA. Yeah. And then number one, paper with the code number 2020. 2020 under the name Zagi from mechanical engineering of ITB. Okay, so I think we want to congratulate the winner of this best paper presenters. I think, yeah, we can congratulate them by, yeah. Sorry. Perlu di ini deh. Yeah. All right. Okay. Can Mr. Zagi show himself so that we can take picture of you all guys? On Harlia Rahman et al. No, not that one. Ariadi, yes, but he's already there. All right. I think, yeah, I think 3 is enough. Yeah. Okay. So the committee here will contact you, and let you know about the further process for the prize. All right, I think that's all from me. Oh, yeah. Can we take a picture of you? Who will take it? Yeah. Yeah. Okay, the moderator will shoot a picture of us all. Excuse me, Mr. Haryadi, can you please, Haryadi, yeah, all right. We want to take a picture of us. Mr. Haryanto, can you show your face, please? All right. How about Mr. Moderator? Have you finished? All right. Thank you very much, Mr. Eric Iswandi, Mr. Haryadi, Mr. Dwi Haryanto, and the other winner. Congratulations again from us. Thank you. And back to our MC now.
Okay, congratulations again to the best presenter, the 5 best presenter. And again, to repeat the information, the committee will be in touch with you regarding the rewards. And now, ladies and gentlemen, we are arriving in the end of the MICS 2020. To sum up our conference, we are inviting University Secretary of Institut Teknologi Bandung, Profesor Dr. Ing Insinyur Wijaya Martokusumo, who will share the conference summaries and recommendations from the two days MICS 2020. Please welcome Professor Wijaya Martokusumo.
Thank you so much. Good afternoon, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Dear colleagues and friends, I believe that during these 2 days, all of us have been able to obtain an interesting discussion in this Medan International Conference on Energy and Sustainability 2020, which the main theme is energy, COVID-19, and the changing world. We have learned a lot from all sessions delivered by the amazing keynote speakers, 6 keynote speakers, and 21 invited speakers who have shared their interesting words. There's another 53 scientific papers that shared by a registered oral presenter and involving more than 600 registered participants. All this conference contribution come from various backgrounds: governments, state-owned enterprises, academics, NGOs, and students from different countries who have concern, attention, and passion in the energy sector. There are 8 different tracks of perspective toward energy issues in the MICES T20. Conventional fossil fuel energy, new and renewable energy, sustainable development goals and environmental challenges in energy sector, energy and regional development, energy economics, energy security and defense, energy education, and decentralized energy development. In terms of sources of energy, we reach a wide range of energy sources discussed in this event, such as coal, oil, natural gas, wind, solar, hydro, bio, geothermal, and even nuclear. Furthermore, there are also some more to mention, such as the battery technology, the lithium battery for energy storage purposes is also discussed in this conference. Ladies and gentlemen, we are very grateful for these distinguished speakers who have passionately shared their presentation in these following subjects: bioenergy from Professor Semida Silveira, Sweden; energy economic from Dr. Oki Muraza from the King Fahd University; energy and climate resilience from Professor Tatiana Vilatova, the Netherlands; Professor Priyono Sutikno, Head of Renewable Energy Center, Institut Teknologi Bandung; Dr. Makati Harta, ITB, D100 researchers; Dr. Dani Pujianto, New Imperial College London; Dr. Ahmad Perwira Tarigan, Sumatera Utara, and also other speakers. On the first day of the session regarding potential of bioenergy in Indonesia after the pandemic becomes an interesting discussion because it is related to the North Sumatra potential in palm oil provision. Even though this conference was held via the online platform, this conference is hopefully can bring intense and global knowledge sharing so that the latest finding and experience from backgrounds and interests can be shared and challenged. Furthermore, we also expect this conference can facilitate a warm and conducive environment so that the previous and current ideas in the energy sector can be fairly criticized, and eventually new ideas then can be produced and developed. Moreover, 2020 is a tough year for almost every country in the world due to the global pandemic, COVID-19. This situation brought multiple implications in the energy sector worldwide. We do really hope in this two-day conference, we get the new insight to rise again after pandemic COVID-19 and make a contribution to energy development. This conference is hosted by Ikatan Alumni ITB Sumatera Utara, North Sumatra chapter of the ITB Alumni Association, with close collaboration with Institut Teknologi Bandung and Universitas Sumatera Utara from Indonesia. This conference is also supported by the Ministry of Energy and Mineral Resources and also involving industries and researchers in varying related aspects. It is a distinct pleasure to join you today at this closing ceremony of Medan International Conference in Energy and Sustainability, an event of 5th ITB and Indonesia Higher Education of Engineering Centennial International Conference. I am sincerely grateful to all of you who have tried to devote their thoughts and enrich the coverage of issue in energy. I would like also to extend my congratulations to the organizing committee of MISIS 2020 on hosting this significant event. Finally, on behalf of the Rector of ITB, Professor Reni Wirahadikusuma, I would like to thank all of my colleagues on the conference committee who have prepared this conference with their heart, also to our sponsor, the diamond, platinum, gold, silver, and bronze. Without your sponsorship, this conference would not be the same. Once again, I would like to say thank you very much for your contribution to this vibrant virtual conference. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor Wijaya Martokusumo, for the heartwarming closing speech. Dear distinguished guests, speakers, and participants, the MICES 2020 has officially closed. Your presence helped to make this event a great success, and your enthusiasm and positive spirit helped make our time together both productive and fun. Our sincere gratitude to all parties that make this two-day conference possible. We wish you all the best and hope that you continue to be engaged with the IAITB Sumatra, North Sumatra chapter of the Institut Teknologi Bandung Alumni Association. Again, thank you very much for your participation and a warm regards from the committee of MICES 2020. In Harmonia Progressio.
Wijaya kita foto-foto dulu Kak. Oh gimana? Kita foto dulu. Oh ya baik. Oke.
Kepada to all our participants that are still online, we would like to invite you to take a collective screenshot as a group photo. So please turn on your camera, and with my mark, we'll count. 1, 2, 3. And one more time, give your most warm smile. And I'll count again. 1, 2, 3. Thank you so much.
Boy. Assalamualaikum Pak Boy.
Pak. Yuk.
Ya. Akhirnya udah selesai Pak Boy ya.
Terima kasih banyak. Terima kasih.
Ya, sama-sama. Akhirnya. Udah sampai setahun lebih nih Pak Boy.
Sukses, terima kasih.
Terima kasih Pak Boy.
kasih, alhamdulillah, terima kasih semuanya sudah selesai ya. Terima kasih banyak. Teman-teman semua yang bantu, terima kasih.
Terima kasih banyak Pak Boy. Senang ketemu Bapak lagi Pak. Kelihatan
Sama-sama.
sehat-sehat. Salam Medan
Terima
Pak.
kasih sama-sama.
Terima kasih Pak Boy.
Terima kasih Pak Said. Alhamdulillah sudah selesai ya. Terima kasih banyak.
Pak Boy manggil nama saya tadi, Pak.
Iya. Makasih Pak Said, sudah sukses
Iya,
luar
Pak.
biasa nih.
Alhamdulillah, sama-sama Pak Boy. Terima kasih, Pak
Alhamdulillah
Boy.
sudah selesai ya.
Udah,
Nanti ketemulah. Insya Allah.
Iya Pak. Iya Pak, iya Pak. Tadi yang Bapak panggil itu sepupu saya Pak.
Oh.
Mungkin makanya agak mirip ya
Suaranya
Pak Boy.
mirip ya.
Oh iya Pak ya.
Suaranya mirip. Salam buat semua, buat Pak Rektor. Budekan nggak kelihatan, Budekan.
Budekan nggak kelihatan Pak. Lagi ada kegiatan kayaknya Pak Boy.
Ibu Ita kemana Ibu Ita?
Ibu Ketua ada Pak. Dicari Ibu Ketua yuk. Sama Pak Boy.
Ibu Ketua kemana ini Ibu Ketua?
Biasanya dekat Ihsan itu Pak.
Oh iya.
Iya Pak. Udah bisa tidur agak tenang sih Pak nanti malam Pak Boy.
Iya, terima kasih banyak, terima kasih. Monggo.
Iya Pak.
Itu udah bisa senyum dia.
Langsung tidurnya di Marriott juga atau gimana nih? Pulang
Di Marriott langsung tidurnya.
Udah Pak, tadi malam Pak, satu malam aja Pak.
Nanti kalau kelamaan marah udah Pak.
Iya.
Baru agak segar sedikit. Nah, yuk. Nah, kami
kemana Udaif?
Udaif nggak kelihatan Pak Boy.